Now, now let us explain about the Newton's second law. So first of all, the first law is a qualitative. The main difference between the Newton's first law and second law is the first law is a qualitative. It shows the qualitative examples, whereas the second law shows the quantitative value. Okay, so the second law is the force that is physical cause which change the state of motion of a body when it is applied on it. It means force produce a acceleration. How much force we produce and how much acceleration we get, that we can measure it. That is quantitative. Quantity we have to find out. It relates the force that is measurable quantity like acceleration and mass. So we are having a common example. Take a tennis ball. Gently, a small acceleration produced and it require a small velocity in a certain time because it is soft and it can gain more speed. We can if we pushed hardly, we can apply a more force, it goes with more velocity and it goes cover a more distance. So same way, if we take the other ball, that is a cricket ball, so we need a more force and it takes more force to control also, to stop also. That means it is a measurable quantity. So Newton's found that acceleration produced in a body is directly proportional to the force applied on it. कितना फोर्स न्यूटन ने क्या फाइंड आउट किया, कितना एक्सेलरेशन प्रोड्यूस होगा उतना ही आपको फोर्स प्रोड्यूस करना पड़ेगा. सो लेट अस सी द ग्राफ ओनली. So the two types of graph we are having. So firstly, if the graph is in a straight line, then that means acceleration is directly proportional to force. So secondly, if the force needed to produce a given acceleration is directly proportional to mass, अगर force directly proportional to mass होता है, then also we will having a straight line. So combining these two relation, we will get F is equal to m into a. So next one, we are having a final formula. So that is force is equal to mass into acceleration. So when we get a hyperbola mass, this is a hyperbola graph. Okay, so they are asking about the hyperbola graph. Hyperbola graph is a curve graph. So if a force is applied on a body in a different mass are there, then acceleration produced is inversely proportional to mass. So this is the directly proportional to force is directly proportional to acceleration, force is directly proportional to mass, but this is force is inversely proportional to mass and force is directly inversely proportional to acceleration. So acceleration is also inversely proportional to mass, then we will get a curve graph. Okay, so then CGS and SI unit of force. What is the CGS SI unit of force? Is Newton. What is 1 Newton? This is definitions are very important, students. So try to understand clearly. So 1 Newton is the force. 1 Newton क्या है? Force है. कितना force है? Which when act on a body, किसी body के ऊपर लगा. Body का कितना mass होना चाहिए? 1 kg mass. और उसमें क्या चेंज आनी चाहिए? Produce a acceleration. कितनी acceleration? एक body 1 मीटर दूरी पर गई है जिसका मास 1 kg है, तो हमारा फोर्स कितना लगा? 1 न्यूटन. दैट इज द डेफिनेशन ऑफ 1 न्यूटन. 1 न्यूटन इज इक्वल टू 1 kg इंटू 1 मीटर सेकेंड इनवर्स स्क्वायर. सो सेम वे द CGS unit is dyne. Same way, dyne is the smaller unit of the Newton. So 1 dyne is equal to is a force which act on the body of mass. वहाँ पे मास कितना था? 1 kg. Here mass कितना है? Smaller unit है. That is why it is a gram. So produce an acceleration. There is the how much acceleration produced? 1 meter second inverse square. Here smaller unit of meter is centimeter. So is 1 gram into 1 centimeter inverse square. So relation is very important. So 1 Newton is equal to 1 kg into 1 meter second inverse square. So in 1 kg how many grams are there? 1000. In 1 meter how many centimeters are there? 100. So how many zeros are there? 3 plus 2 5. 10 raised to power 5. So gram centimeter inverse square. So 10 raised to power 5 dyne. So 1 Newton is equal to 10 raised to power 5 dyne. So Newton's second law of motion in the rate of change of momentum. So according to the second law of definition of second law, if the rate of change of momentum of a body is directly proportional to the force, अगर जितना rate of change आया है अगर वो directly proportional force के according है, and change in momentum taken किस side पे होगी, change in momentum is taken place in the direction of which the force is applied. This is very important definition. So explain force is equal to change in momentum upon change in time. What is the formula of momentum? Delta mv upon delta t. This is a general Newton's second law definition, and this is the scientific science mathematical force is there. So Newton, if F is equal to ma, if F is equal to 0, then A is also 0. This means that two conditions. Before that we will discuss the two condition. When does the F is equal to m delta v upon delta t, that is m may hold? This is very important. Write the two conditions. This is the ICSE previous year, last year this question was asked. Write the condition when the this condition F is equal to m may hold. First is when the velocity are much smaller than the velocity of light. अगर velocity बहुत कम होगी velocity of light से, then this condition can be hold. Second, when the mass remain constant. So as I told you, the mass should be remain constant, then only delta v upon delta t can be changed. Okay, so this is the fundamental law of motion. What name the second type of second law? It is a fundamental law. Okay, keep it in mind. So next one is to how can we obtain the Newton first law from the second law. हमने first law से second law कैसे बनाया? F is equal to ma. If the F is equal to 0, then A is also 0. This means no force is applied on the body. अगर force body के ऊपर force लग ही नहीं रहा, is there any acceleration change? No, there will not be a acceleration, also be 0. If the body is rest, it will remain at rest, and if it is moving, it will remain moving in the same direction with the same speed. So a body not acted upon a external force. Body के ऊपर कोई बाहरी force नहीं लग रहा. अगर बाहरी force नहीं लग रहा, then does not change in its state of motion. That is the Newton's first law. So we have derived the second law from the first law. So some examples are there. So while catching the ball, a cricketer withdraw the hands back with the ball. Why? Because to release from the pain. So that means the ball will get the more time to come on the rest. That's why. So when the athlete taking the long jump, then it starts running from the back. High jump, then it starts from the back, or often sand is there or taking long jump. Why? Because the otherwise if there is a no sand, we will not spill a sand over there, then the feet comes rest on the moment. That means the feet will get the less time to come on the rest, so it hurt, give hurt much more. If we spill a sand over there or foam, if we jump on the foam, then our feet gets more time to come on the rest. That is the Newton's second law. So try to read this topic and understand this one, students. Thank you.